Good morning, everyone. Today is Friday, May 21st. We're going to be looking at Unit 7-8, page 10, which is our box and whisker plots page. Our objective for today is very similar to Monday and yesterday. We're still interpreting and comparing different sets of data, but again, we have a new representation of how that data is organized called box plots. So we're going to start with our DIN, review some things about histograms, and then move on to box plots, which are my personal favorite. Go ahead and pause your video here and complete that DIN for me. Alrighty, hopefully you were able to pause the video and write some things down about these two histograms. Looks like we have some test scores from one exam versus test scores from exam 2 of a class. So maybe they take the first test and they did bad and they do better on exam 2, or maybe it's the opposite way. That's our job to figure out. So we can try to estimate our median, just like we did yesterday, by looking at our frequencies here, trying to figure out where that middle value would be. It looks like we have about, let's say, maybe there's 3 there, 5, 10, about 35, and then about 30. So let me go ahead and add those up. 3, 5, 10, 35, and 30. About 83. That number could be a little bit off depending on our actual scale here if you get a more accurate number, but because we have 83 different test scores, we can sort of try to find that middle number. If there's 3, 5, and 10, there's going to be about 18 on this side when there's 30 on that side. And then our middle number would kind of fall in this middle block here, 80 to 89. That's where my median might be. For exam 2, it looks a little bit more symmetrical when we're talking about our shape here. Okay, this one was a little bit skewed to one side. This one is looking a little bit more symmetrical, so I would go ahead and assume our median is actually in this 70 to 79 interval. Okay. Based on that, I might say that students did better on exam 1. The median value was higher. Or if we're talking about ranges, we could actually see that this one kind of starts in this interval and goes to that one. This one also starts in that interval and goes up to that 90-100 interval. And so our ranges could be the same. We don't quite know the exact number within that interval to use for the range, so we can't quite find it. But just based on the two intervals that we're looking at, we could have the exact same range. We could say, using that students did about the same on exam 1 versus exam 2. Okay? There are those different ways to compare our data, looking at the shape, looking at the center, which is our median, and looking at the spread, which is our range. Okay, so you can go ahead and write down any of those things. Draw some conclusions for yourself. What do you think? Which exam did students do better on? Things like that. And then we can go ahead and take a look at our box and whisker plot. I'm going to let you guys know why it is actually called that in just a second. It shows the distribution of hourly pay for fast food workers in a survey from 2014. What do you notice? What do you wonder? So it's kind of showing the wages of different workers. For example, this point here could be, see, I think that would be $10.25. So maybe that represents one fast food place, could be McDonald's. Okay, we're not quite sure yet because we don't know how box and whisker plots work. This line here ends at about $12.50. Maybe that represents Burger King's wages. We don't know yet. What we do know, and what you're going to learn now, is that it's called a box and whisker plot because of the way it looks. We have this box in the middle, and we have our two whiskers on either side. So let's go ahead and draw some box plots. Let's actually figure out why they look like this and what those values could mean. We are going to do a class set of data again. So because we are online, instead for your lesson today, we don't have those other class answers yet. So I'm just going to be making up some for us to use. Okay. And our question today is a little bit interesting. If we were at the park right now, and your teachers were acting as the judges for a monkey bars competition, what do you think your score would be from 0 to 10? Random answers are fine too if you don't quite know. So we can pretend we have a small class size today. Maybe there are 10 students, and we'll say 5, 6, 7, 8, 8. See, that's 5 students so far. Then we'll say 9, 9, 9, and we'll put a 10 at the very end here. That'll be our class data for our 10 students. And feel free to add your own number as well. This list below that is every important piece of information that I need to create a box plot. Okay, 3 of the things we do know how to find already. So I left those ones unbolded. They shouldn't be new for you. Minimum is another word for the smallest number. So we can go ahead and say that's 5. Maximum is another word for the biggest number. We can go ahead and say that's 10. Median is the middle number. So we can find our middle of the data and say that's 8. And then you have these 2 things called a first quartile and third quartile. And what that is after I find the median and I say that's 8, my data is now split in half. Okay. And then the first quartile splits the data in half again. After we find the first original median is right directly in the middle, now I'm only going to be looking at this side. What's the middle of this side by itself? And that would be a 6. Okay. That is our first quartile. We split the data in half again. Now our third quartile is exactly the same thing. Now you're looking at the bottom half of your data, the larger numbers, and you need to find what's in the middle of only that side. You have a 9 there. Okay. They work just like medians, except you're finding the halfway mark of only half of the data. And so basically what we just did is split this data into 4 pieces. We have this first side, we split it at 6. Middle piece, another middle piece, and we split it again. So we have 4 pieces now. Those 4 pieces are going to help us make our box plot. So let's go ahead and take a look at what that's going to actually look like. On my box plot, I need to go from a minimum of 5 all the way up to 10. So I'm going to keep 5 here. And I think I have enough space to actually count by 2 lines. So I'm going to say 6 is here, 7's there, 8's here, 9's here, and then 10 is here. Okay. If we had different numbers, I might have to change the way that I labeled these. If we had 6.5 or halfway marks, then those halfway points would come in handy because we could use those. It really depends on how big of a number line you have to work with. Okay. And then what I'm going to do is draw some lines above each of these 5 numbers. Okay, and you're going to see why in just a minute. This minimum 5, I'm not going to put it on the number line like you think we should do. Normally when we have a number line, we do label things right on the line. But with a box plot, you actually want to draw a little line above it. My first quartile is 6, so I'm going to do the same thing with 6. Draw a little line above it. Median was 8, so we're going to have our 8 there. Third quartile was 9, and maximum was 10. Notice those 5 lines and compare them to our DIN here. I know we don't quite have lines on our whiskers here. Sometimes you might and sometimes you won't. But we've got 1, 2, 3, 4, 5 lines on that box plot too. You will always, always, always have 5 lines on a box plot because these data points that we looked for are called a 5-number summary. They're always going to be the same 5 numbers that you need because watch what happens now. My 3 lines in the middle can be a little bit bigger. Those are going to make my box. I know it's quite messy on my screen. Don't have a fancy pen like Miss Martin, so my handwriting is a little bit messy virtually. And then my last 2 lines are going to create our whiskers. Okay, so we can see that general shape. Our 5-number summary helped us to create a box plot. We're going to do the same thing with some data here, except we're not creating it this time. We're finding some of those values instead of using the values to make the box plot. So it's a little bit backwards. Then we'll be doing some comparisons. We'll be doing some more practice with drawing them, things like that. So let's take a look at this one. This data shows the information I collected with my other 7th grade class about that same question, so the monkey bars question. In this case, they did have some half values, so we see 6.5, 7.5, and some different numbers here. And now we want to find the median of this box plot. So just like we did when we were creating it, the middle line was our median. So when I'm looking at a box plot, trying to find the median, I'm just going to find that middle line. It's right between 8 and 8.5. So I'm going to say that's 8.25, directly in the middle. With my range, we know that's the maximum number minus the minimum number. So what I'm going to do is I'm going to use my whiskers. I'm going to find the maximum. It looks like it's about 5.678, about 5.8. Sorry, 9.8. And then my smallest number, my minimum, is my other whisker over here. It looks like it's about 6.6. And when I subtract those, I should get 3.2. That's my range here. Okay. And the very last question they're asking us here is a little bit new. We haven't heard of an interquartile range, but it's actually very similar to a regular range. Instead of using the maximum and the minimum from the whiskers, you're kind of going to use the maximum and the minimum from the box only. So you're using that 3rd quartile number, which looks like it's 8.7, minus the 1st quartile number that created your box, which looks like it's about 7.8. And so for this one, we have about 0.9 of a difference there. That's going to be our interquartile range. Very, very similar to our regular range, except we're only using the values from the sides of those boxes. 3rd quartile minus the 2nd quartile, or 1st, sorry. 3rd minus 1st. The median is kind of that 2nd quartile right in the middle. Now that we know how to not only create a box and whisker plot, but also start collecting some information about them, we can also use that to compare data. So Ms. Diaz collected data on the number of hours spent each week playing video games by the 6th and 7th graders at Lincoln Middle School. How did the number of hours playing video games compare between 6th and 7th grade? What we can say is talking about those big numbers that we can find. Our minimum for 6th grade is higher than the minimum for 7th grade. The maximum for 6th grade is higher than the maximum for 7th grade. Okay, but the median of 6th grade looks like it's lower than the median for 7th. The first quartile looks like it's lower as well. And the third quartile looks like it's lower as well for 6th grade. We can find the range. 29 minus 9 is about 20. 27 minus 6 is about 21. So the range is a little bit bigger for 7th grade. And we can use all of those data points to draw some conclusions. We can just write those down, saying that the range for 7th grade is bigger. Okay, the median for 7th grade is bigger. And we can find that interquartile range again as well. Looking at our third and first quartiles, this one is about 22.5 and then 14. So 22.5 minus 14 would give me 8.4. This one looks like it's directly on 21, and then maybe 11.5. If I subtract those, we've got 9.5. And so the interquartile range for 7th grade is actually smaller. Okay, we have some different things here that could help us out a little bit. Depending on what piece we're looking at, the 6th graders might play video games more, or the 7th graders might play video games more. Okay, and that's your decision to decide based on the data. And then we have some practice questions. Amani is doing a survey with her class. We can make a box plot finding those 5 main things, okay? So when you are doing this on your own, you want to find the minimum, okay, smallest number, the first quartile, median in the middle, the third quartile, and the maximum, biggest number. Okay, always, always, always find those same 5 things by looking at smallest, biggest, splitting your data in half, and then in half again, and then half one more time. Okay, so basically you're making those 4 equal parts that are going to help you draw your box plot. You're also going to do that for the Keandra question, and then you have some questions here to answer about the data. How does the range compare? Which one's bigger? How does the interquartile range compare? Which one had a higher median? Things like that. Your exit ticket is another set of box and whisker plots to compare that are given to you already, so you don't have to draw that one. And again, you want to make sure you're mentioning the median, range, and interquartile range. Those are the 3 things we're using to compare these representations of data. Then you're going to do your self-reflection and complete independent practice 38. That's it for today.